Rational equation. A rational equation is an equation containing at least one fraction whose numerator and denominator are polynomials. It is an expression written in the form P over Q, or in Q must not be equal to 0, because if Q is equal to 0, that will give us an undefined expression.
Good day, I am Laika Marika Hess. Today I am going to show you an example of a rational equation, and let us try to find out the solution for this rational equation, which is x minus 4 over 4 plus x over 3 equals 6. So the first step we are going to do is to find its LCD, or least common denominator. After finding the LCD, which is 12, we are going to put it in each side of the equation. Then multiply it prospectively. So 12 divided by 4 times x minus 4, the answer will be 3 times the quantity of x minus 4, plus 12 divided by 3 is equals to 4 times x. It will be 4x. And then 6 times 12 equals to 72. So as you can see, there is parenthesis left and we are going to multiply it. So 3 times x minus 4 is, we will get the answer 3x minus 12, then bring down, plus 4x equals 72. So after that, we are going to combine like terms. So 3x plus 4x is equals to 7x equals 72 plus 12 is equals to 84. And since we are finding x, we are going to divide each side by 7 because it is divisible by 7, and the answer will be x equals 12. So here is the complete solution of the equation x minus 4 over 4 plus x over 3 equals 6. So now we are going to check if our answer is correct. So for the checking, we are going to substitute x into our answer, which is 12. So it is going to be 12 minus 4 over 4 plus 12 over 3 equals 6. So 12 minus 4 equals 8, copy over 4, plus divide 12 divided by 3, 4, and equals 6. So 8 divided by 4, 2, bring down 4 and 6. So 2 plus 4 equals 6, and bring down equals 6. So our answer is correct.
A rational inequality is an equality which contains a rational expression. The trick to dealing with rational inequality is to always work with 0 on the side of the inequality. A rational expression changes its sign only at its 0 and it's undefined.
So hello, today we'll discuss about rational inequalities. So here we have the example of 2x over x plus 1 is greater or equal to 1. So we'll write it as 2x over x plus 1 minus 1. We will transfer the 1 here, so we'll put it 0 in here. So we'll make the x plus 1 as denominator. So x plus 1 divided by x plus 1 equals 1 times 2, x equals 2x, and we will put the negative 1 here. So the negative 1, we will multiply it by x plus 1. So negative 1 times x equals negative x, and negative 1 times positive 1 equals negative 1. So the answer for this one is 2x minus x minus 1 over x plus 1. So 2x minus x minus 1 equals x minus 1 over x plus 1 is greater or equal to 0. So the answer will be x minus 1 equal to 0 and x plus 1 is equals to 0. So we'll additive inverse it. So this will become x equals to positive 1, and this will be x equals to negative 1. And so next we will put it in a line graph like this, where we will put our answers negative 1 and positive 1. So we will try first the positive 1. X equals 1. So x equals, so x minus 1 over x plus 1. So substitute the x. 1 minus 1, 1 plus 1. So 1 minus 1, the answer is 0, and 1 plus 1, the answer is positive. So 0 divided by positive equals positive. So this one is true. So we will put a closed circle here or solid circles to indicate that this is a true solution. So next put we will try the negative one. So x equals negative one. Same here. We will substitute the x. So negative 1 minus 1 over negative 1 plus 1. So negative 1 minus 1, the answer is negative. And negative 1 plus 1, the answer is 0. So negative divided by 0 will be undefined. So it will be undefined is greater or equal to 0. So this one is false. So we will put here in the negative 1 an open circle. So next is we have to find the regions. So what regions are true and false? So we'll find the number that is greater than negative 1. It is negative 2. So we will try x equals negative 2. So substitute the x's. Negative 2 minus 1 over negative 2 plus 1. So negative 2 minus 1 equals, the answer is negative. Negative 2 plus 1 is, the answer is still negative. So negative divided by negative will be positive. So this is true. So we will put a star here to indicate that this region is true. So next is we will find a number that is between negative 1 and positive 1. So it is 0. So x equals 0. So substitute the x. 0 minus 1 over 0 plus 1. Then 0 minus 1, the answer is negative. So 0 plus 1, the answer is positive. So negative divided by positive will be negative. So negative is equal or greater to 0. So this one is false. So we will not put a star in this region because it is false. So next is we will have to find a number that is greater than 1. So the number greater than 1 is 2. So we'll put here x equals 2. Then 2 minus 1 over 2 plus 1. 2 minus 1, the answer is positive. 2 plus 1, the answer is positive. So positive divided positive equals positive, greater or equal than 0. So this region is true. So we will put a star here. Then in writing your answers, this will be the method. So open parenthesis, negative infinity, comma, negative 1, close parenthesis. So we will put close parenthesis here because it is an open circle and this answer is false. So until, up until 2, bracket 1. So bracket will be used because this is the true answer and it is signed by a closed circle. So comma plus or until positive infinity, close parenthesis, and that's our answer here. So I hope you understand our topic now. Thank you.
Find asymptotes. Vertical asymptotes equate denominator to 0. Horizontal asymptotes. Select at least 2 within each partition graph. Identify intercept. X-intercept, let y equals 0, then solve for x or equate numerator to 0. Y-intercept, let x equals 0. Identify domain except the vertical asymptotes. Identify range except the horizontal asymptotes.
Good afternoon, everyone. So, example for graphing rational function. Fx equals 2x minus 2 over x plus 2. First, we must find the asymptotes. First, find the vertical asymptote. To find the vertical asymptote, equate denominator to 0. So, x plus 2 equals 0, x equals negative 2. Horizontal asymptote, n equals 1, m equals 1. It is 1 because 1 is the highest degree of the numerator. It is m equals 1 because it is the highest degree of the denominator. So, since n equals m, then y equals a over b, where a is equals to 0 and b is equals to 1. So, y equals 2 over 1 is equals to 2. Then identify the intercepts. X-intercept, let y is equals to 0. 2x minus 2 is equals to 0.
2x equals 2.
Divide both sides by 2 to remain the x. So 2x divided by 2 equals x.
So x is equals to 1.
X-intercept is 1, 0. Y-intercept, let x equals to 0. Substitute the x by 0. So y equals 2 times 0 minus 2 over 0 plus 2. Y equals negative 1. So the y-intercept is 0, negative 1. Next, graph. Choose at least two numbers before and after your vertical asymptote. Our vertical asymptote is negative 2. So, negative 3 and negative 4 are numbers before negative 2, and negative 1 and 0 are numbers after the vertical asymptote.
So the table will be like this.
To find fx, substitute the x from the given example. So the fx are 5, 8, undefined, negative 4,
And negative 1.
so the graph will be like this. Domain. The domain are all real numbers except x equals 0. Range. The range are all real numbers except y equals 0. And that would be all. Thank you.